It's Monday. Day. It is Monday. Oh, coffee. So today we're gonna keep trying to get the program to work. I don't know where we are. Just gonna have to look at the errors as we start. Right, the shader is broken right now. It's a harsh place to start immediately. I don't remember this though, like why is this broken? Should static light areas count? Right. Yeah, we've changed how light areas are supposed to work. Alright, so how is this done right now? I mean, it's not really. We haven't properly set... We haven't properly made the function in object, I think. No. Well, maybe. Oh, I am handling it. Should this be an else, though? I don't think this should be an else. Yeah, this should not be an else. Okay. Then this needs to... Right, this is called areas count. Now it's areas stride. which is a uint 2. So we should just need to access it. We should just need to get the area index. And that's it, pretty much. Light area size is being set here already. As an int. Yeah, sure. So I do have to go through the light cast. It needs to be changed to some degree, I believe. So if light area index is less than 1, right? Light area position. World area size. What is that? This should be an int, shouldn't it? Is it a float? I don't like it being a float, but we can work with it for now. I think this is basically right. But I might still need something like this. We need it. We need something like this. And then what is this here? Kernel upload. Static light area data. One way you could do it, I think, that would allow me to not bother with count and stuff. is to always put in an additional stride. Or an additional entry. Because like right now, I have to have one buffer that just contains the data. And then I need to have another buffer that contains count. No, it contains starting index and count. So like for world 1, starting index is here. Oh, wait, it wouldn't work. I mean, you could. It's just... I need to have one buffer that handles the handle telling us like where in the buffer we should read. And if I at the end of that buffer just write a certain data snippet, that way we could just for loop through it until we find that data snippet, and then we know that that's where it ends, instead of reading until we get to the end and then enter into undefined data, right? Or out of scope, rather. But this is where things are gonna get tough, because it's so much to keep track of. Upload dynamic area data. Baked stride, staging count. Upload dynamic area data. Right, and it does this shit. And see, I was gonna do something like this here. Compute world index container. And this contains building data, building transparency, static light data, static light area data, blah, 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 blah. This doesn't make any sense. Building trans... How is this a uint? Like, what was I thinking here? Uint object data. This has to all be the count, right? Because nothing else makes any sense. And then let's see structs. Did I use this already? Yeah, this is count. Let's call it count then. Well, okay. We can't do that. We have to do it this way. Oh, come on. Okay, that's then less confusing. This is a stupid name. Compute world index container. It should be compute world data count container. Let's just be super explicit. I think this is wrong. We want to write this. This should be a dispatch, like we're doing in the others. This needs to be a kernel. I think. The byte offset x times 4 So x times 4 it's in byte, so it's right. Because we're reading at byte 0, then we're reading at byte 4. Because we're hopping 32 bytes or 32 bits at a time, minimum. So that means this is an integer. So that means this is times 8. Right? Wait, maybe I'm stupid. Yeah, I am. No, I'm not. Maybe? Maybe I am, maybe I'm not. I'm not sure. Because we're writing raw data to a buffer that we then use to translate into real or structured data that we're putting into a structured buffer. But I was just thinking, like, why do I need to do that? Why can't we just, like, move the bytes in and that's it? But maybe it needs to be, like, rebound or something in some manner. I don't know. But we need to say world index, compute world index container. But I'm gonna change that name. Do that. And then we say data container Why do I have 10 things here? Guess I've changed something, right? Because here we have a static light area data count. Here we have static light data count. I don't need that one. Static light source matrix total count. But yeah, because we don't actually need to know the data count of the light or the shadows. And we also have static shadow and dynamic shadow. Basically. And so we're gonna have to make a bunch of things here. But I'll be right back. Okay. Let's actually call them what they are. Or what? This is what? This isn't stride. This is like. Start index. Right, and then this is load start index. It's been a while since I did this, so I'm not entirely sure. This should be world index. Fuck. Yeah, this is unnecessary. I just remembered. Isn't it? I don't know if it is. So I feel like they're bullshitting. Some degree, like from what I understand, We figured something out, but what was it exactly? It was a while ago. I don't know if I still have that history. Let me see. Yeah, so we don't need to do this at all. So we just did this for naught. It's cool. Yeah, because as long as you keep your buffers as immutable, they're not immutable, right? Because it when you look at it, it sounds like sub-updates is like the way you should be using Unity compute buffers, but it's actually the opposite, where the immutable buffers should be used in almost every case unless you have a specific use case, because they're not immutable. Because what it sounds like is that you can only upload like once to them when they're initialized, but that's not true. You can just do set data to them whenever you want. It's just that they're immutable in the sense that the CPU doesn't map to them directly, but Unity's like set data and stuff are actually like a CPU to GPU allocator. They basically do what I'm doing here. They're uploading raw data and then patching it in more or less. So it actually works just fine. And you don't have to really do anything. But it doesn't actually hurt. I'm gonna keep this commented because it doesn't actually hurt to have this. Because I might want to use this later anyway. But we'll see. So this is actually completely legit. So then all we have to do here in the lightcast, when we are reading the compute static light areas count, all we have to do is we instead say, and duplicate this, world compute world index container buffer world index dot static That's why. Also, I'm gonna change the name of it. Compute world data count container buffer. Compute world data count container buffer dot static light area data count. And we're gonna return stuff red and green. I wonder if it costs anything to access a I wonder if it costs anything to access a buffer compared to just like setting it as a local a cached value locally. Static light area data count. Honestly, no. No, this isn't what this should be. If light area index is less than 0, it should be like a maximum. What's the maximum amount of areas? I'm just thinking, how do I... int max area index equals this is a value that should just exist. Should be written somewhere. It should be like a global. Shouldn't need to be calculated every time. Light area size. Light area count. I'm just gonna make a note of that, and then we just pretend like it's set. Set light area count in shader needs to be the maximum amount of light areas in 1D. And then, yeah, this should be that. Maybe that should be a part of this. Because it isn't. Map size combined. Because I don't think that would be accurate. Necessarily. Because I could just take map size combined. That's the... How many tiles are there? As an integer. Which, by the way... 2 billion. Yeah, we're not at 2 billion. Alright, I'm a little spaced. Map size combined. Okay, let's do the math here. So let's say we have 100 times 100 times 10. Let's say 20. That's gonna be 20, 1, 2, 1, 2. That's 200k. Then we divide that by 12. That's 16666.67. And then what if we instead do 100 divided by 12? That's 8. Eight times 8. And then 20 divided by 12 is 1.6. Wait, hold on. You know, this needs to be 9. 9 times 2. That's 162. Yeah, no. Has to be done this way. Because it needs to be sealed. So this isn't enough. So let's add another thing here. Area. Area count. World area count. And this is 9. Light area map size combined. Am I using this? But then light area map size, how is that set? It's sealed. Yeah, as long as that is sealed, we can just use light area map size combined. Like that. And then we go up here. And then this was... World area count. Now this, I hope we can get rid of. What am I doing here? Yeah, this is BS. I don't want to do this anymore at all. And I think we can just delete it straight up. Just like that. Which is gonna be huge, because this is ass. Like, really, really ass. Basically, what I was doing was... I was only counting which area does a light exist in based on its coordinate only. And because of that, I made the lights have like a maximum size that could only reach across two areas. Like the one it's in and the ones it's next to. It was a horrible solution. I don't know why I even did it like that. It was so bad. And so because of that, I kind of calculated like which side or which quadrant of its area is it in. And then I created like an area index array that contained like 8, because it's got a z-axis too, right? So the 8 most neighboring areas. And then I checked there, like it was so stupid. Because here now I'm looping. I have a loop within a loop just to manage that. And that's why this is going to take some time, because I have to get rid of some of that bullshit. But it should just be removing this index. Or this outer loop here. Holy fuck, man. So now the way it works is that we're just gonna check which area are we in, and then it's just gonna check for the lights, and then we're gonna trace all the lights. How do we do that? So here we have a light area index here. So all we need to do, compute static light areas, light area index. Got one channel. Uint. Okay. So what we need to say here is int start index equals and int count equals I think. Where is that written? Is it written anywhere? Yes, here. Start index count. Yeah. So I don't know why copy paste is so ass. Anyone else notice that? Copy paste since like I don't know if it's Windows 10 or if it was I might have been ass in Windows 7 as well, but I think it's Windows 10. Half the time it doesn't take. Like I copy so often and then it doesn't copy anything. And then you have to go back and you do it again. Like it's same thing with print screen. I mash Control C. I always press Control C 2 to 3 times now to get it to actually take, and it still doesn't take sometimes. It's so weird. What happened to compute light data? Oh, I'm confused. Okay. Oh, it's baked into compute object data now. What is this? Light CTD, light tile data. So it's gonna be compute object data equals compute object data compute light compute static light areas li yeah, and then that's a color, a light size, a position. Yeah, so here we're doing the static lights. And then the thing is, we're gonna have to do the same thing again but with dynamic lights. And that's what kind of blows here. Because as you can see, it's kind of long. I feel like the lightcast should maybe take a buffer. That way we can customize this to... We just run it twice, and it just runs against the static and the dynamic, depending on what we pass in. Because I think this should... Yeah, this should be the only... We'll see. Because it should kinda... It should just be this now. Before I was doing shadow and light casting, but it should only be light cast, because the pixels should be lit by a light source. Otherwise they should be unlit, I think. Which means we need to use the sun and everything to light them. And that's kind of heavy, but I think it's also fine. It's running really poorly right now, but that doesn't really have to do with what we're doing. It's more to do with the fact that the shader code is poorly written right now. Whoa! Hello, Lemur. Thanks for the raid. This is a uint. So this is... We need 2 buffers here. This is the uint 2. This is the bridal buffer. And this is the... emitter buffer. Suppose. And that way, instead of... Take care. Instead of compute static light area stride, we'll say stride buffer. Static light areas. This is then emitter buffer. And then this is an emitter buffer. I think that should work. That way we can reuse this script for both dynamic and static light. And here we have a CS light source, but the light source is now just a light source object. So it should just be like this everywhere. Light source object. Light origin building. And here we have some more error. Huge shadow source count. Yeah, this is where it gets a little complicated. But I think it shouldn't be this big of a deal. Like, what am I doing here? Huge shadow areas. I feel like I should be able to remove all, this whole thing almost. Not necessarily, but... Because all we need to do, we don't need to find like what object we're intersecting with, really. We need to find any object that we're intersecting with. Unless it's transparent, then we need to find multiple. And maybe that will complicate it like this. But otherwise, all I should need to do here is we should look for whatever objects exist in the current area. And then we see if the light collides with them in its trajectory at all. And I wonder if that's best to do first. Because, let's see, how am I doing that right now? Light step limit. Wait, where was... Yeah. It does need to be a nested for loop, but are we doing it unnecessarily? Because here... Here we're looping through the light sources. And so... all we should need to do... No. It needs... It needs 2 for loops inside each here. But right now, we have a for loop here, which then has another for loop. Yeah, I think this is hyper over complicated. It should work like... You have an outer loop that loops through. You have the pixel. We're rendering a pixel. So we fetch the pixel's light area by checking where it is. And once we have the light area, we can then fetch containing lights and objects. And then what we need to do is we need a for loop through lights. And in the for loop through the lights, we need to march towards the for loop, or towards the light, because we need to see if it collides with the tiles. But before we do that, we should collide with an object. So here we need to have for loop through objects in area. And then after that, it needs to be a for loop through tiles. For loop march through tiles. And then if any of those fail, collision equals immediate break and no, immediate collision in object equals immediate continue to next object. Collision in tile equals immediate exit and draw shadow. And it should never the collision with the objects. I don't know which order is better. Maybe doing the tiles first is better. Because I don't know. Yeah, I think so. Well, actually, hold on. No. Collision in object. Okay, so a collision in either. So it doesn't really matter that much. I feel like there's no real good choice here. Basically, okay, a collision in object is an immediate exit and continue to next light. And this is actually the same, and continue to next light. Yeah. And objects? The objects... The reason I'm not sure where to start is because the object doesn't need any ray marching to calculate. But I don't know if calculating, like, let's say there are 10 objects, is calculating the intersection on 10 objects faster than ray marching through the tiles? Because if it is, then I don't know. It just doesn't matter. This is something I feel like we just have to do it and then just move the code and just flip the order and just see which one runs better. I don't think there's any immediate logic you can discern here what would be better. I don't think it really matters that much either. Either way, it needs to have both. And so what's the What's the structure now? Pixel, light, area. We loop through the containing lights and objects. I think. And then right now we are... This is for looping, for loop through lights. And here we are... For loop through tiles. That's what this is, I think. This is the Raymarch algorithm, or the DDA algorithm. Oh, wait, hold on. Yeah, okay. So we're targeting the light. Yeah, so we're Raymarching through the tiles to the light here. And this is where I'm confused. Light area index is less than compute static light areas count. Yeah, here's where we're doing some bullshit. And here we're looping through shadow sources. Yeah. So this is how it is here. We're looping through the tiles, and in there we are for loop through object every tile, I think. And that's horrendous. Oh, this is too heavy for a Monday, bro. Holy moly. Ugh. But it's not that hard. We have done this 10 times at this point, but... we should more or less write a new for loop here. Why won't it fucking use the fucking snippet? It's because there's no snippet here. I don't know exactly. Okay, so what do we need here? Ah, shit, it's actually not that easy. Necessarily. We might need to have a nested for loop here. Which is kind of scary, because you can't have... The GPU is really bad at nested for loops. Well, it's not really bad, but it's pretty bad at it. And if you nest too many for loops, it'll literally just stop working. And I think that the scope of your variables as well, they fall out of scope if they're like too many layers like below as well. And it's only like 3 or something. It's not even that much. But the issue is that it's easy enough to say like, yeah, we have some light areas here. And we're rendering here. Rendering this pixel in this zone. And then this zone contains a bunch of lights. Contains light 1, 2, and 5. Okay. And light 1 is here. It's right there. Light 2 is down here. But light 5 is over here. It's just big enough that it falls in here, so it counts as it existing here. And that means that we have to march all the way over to this light. This is where it gets complicated. because then we'll also, here, will contain certain objects. We'll contain object N1, N2. Object 2 is over here. But object 1 is over here. This is where it becomes annoying, right? Because we have to go over here, number 5 exists here. So we can march towards number 5 and check if it collides with tiles. That's easy enough. You just go, and you just go through the tiles. Because the tiles don't have anything to do with the areas. But then, in order to check if we're colliding with this here, we now have to load every single area between source and target. And then we need to check all of the objects in between. That's the issue. So and the next issue is that there are no lists in HLSL. So we can't do this, we can't allocate this dynamically in a way that makes any sense. So the only way to do that would be if we have a buffer, but that doesn't work either. It is doable. But it's terrible. Because what I would have to do is I would need to allocate a list or an array of integers that's like, let's say, (64), 100 in size. However many objects we want to support being able to collide with. Because at some point you're gonna have to say, fuck it. Because it's gonna be too many. But it would mean that every single pixel needs to allocate an array of integers that's a certain amount in size. Which I think is potentially really bad. What's 1920 times 1080? 2 million times 32 times 64. How much is that? (500 megabytes), but I don't think it's that big of a deal, actually. Because the reality is, it'll only do it per wave. So let's say we allow 64 integers. That's 64 times 32 times 64. I mean, wait, hold on. Hmm. Yeah, that sucks. If you allocate, yeah. It would have to be 4 loops. I was thinking of like trying to like gather up the objects that we would need to collide with. But because that's a dynamic size, it doesn't really make sense. The insight is that redundant comparisons are cheap on a GPU. You'd rather recheck an object twice than pay the cost of storing a deduplicated list in per-thread scratch space. Memory latency and occupancy are far more expensive than a few wasted ALU ops. Right. So, okay, in that case, it basically is gonna have to be like this. We need to find our current pixel. We find its light area. We check what lights and objects they contain. We for loop through the lights. And here, we for loop through all areas in between source area and object target area. But that'll be in here, right? For loop through objects in area. That'll be in there. We could sort them. But that's going to be a profiling thing. But what we could do is I could sort objects by distance inside of each area. But that comes with the overhead of having to go through and check, like whenever a light changes, we'd have to go through and check those areas and sort them by light distance to that area, based on like area distance specifically. Because if I do that, then we create a system where objects that are further away are, or light sources that are further away are less likely to be checked, because no, it doesn't matter. That doesn't matter. Because all the light sources need to be checked. So it doesn't matter. No, that doesn't matter. Yeah. I actually, if I'm gonna be honest, I didn't know about it back when I started, but I think if I were to start now, I wouldn't use ray marched light. But I would rather use, what is it called? Propagated light. I think. But I'm not sure, because I don't know. I think with the propagated light, it's cool, but it's kind of hard to create like rounded light that actually looks right, I think. But I think you can still. But it's a challenge for sure. Because you need to check like surrounding tiles and stuff, and that would be kind of ass, but you could do that. And then create like a normalized look. I don't know if normalized is the right word, but not like square based. Because I think the light propagation technique is extremely strong when everything is more static. It seems to have really good results even with fully dynamic systems where you flush the propagation every single frame and update it every frame. But yeah. It basically just works like water propagation works, where you move it into like nearby tiles. And it has pretty good results. Because you can kind of make it bleed in like the surroundings, or like through corners and stuff, a little bit, which kind of makes it have this more natural feel, where light isn't just on or off. So it actually bounces some light around that way, and it just feels a little bit more natural. But I haven't tried using that, so I'm not gonna. But then here we're looping through light sources. And then this is gonna be we're gonna have to say int target area equals cs light source object dot position divided by light area size (3D to 1D). This one. And then we need a tile position, which is position divided by tile size. Hello, Jano. How's it going? What is tile size? Tile size is a float 2 dot xyy. And then it also needs to take a matrix size, which is I wanna write a function. about you? Yeah, it's alright. Getting some stuff done. Public well, it's a uint get light area index. And then we need a float 3 position. And I feel like we should be able to do that with just that. So then int 3 tile position equals position divided by tile size, x, y, y. And then the tile position is gonna be int 3 area index equals tile position as a float 3 divided by area size, what is it called? Cloud size, tile size, world size. Light area size. Yeah, okay. Divided by light area size. Oh, I see. It doesn't work because this is being declared after light area size. Oof. I'll be right back. Here we go. And then this is gonna need to be a seal. We seal to int. And then we have the area index. And so we're gonna have to say now this is no longer data count because I need this world size. Oh my god. Basically, everything that is like custom to each scene should be contained in this struct. And that way we can just set, instead of having to set like all of this shit every single time that we need to execute the shader, we just set world index, and then we just access this and read that. I don't know what else it would need though. I'm not prepared in my brain for this. Needs to convert it to a float, otherwise we can't divide it properly, because we need the remainder. Well, I mean, this shouldn't need to be calculated. This should just come preset here. World area size. Let's call it area world size. Then we just have that. Something like that. Hello, Charles. That might be okay. Ooh. Right, so target area. We now want to say get light area index. That's all. Lots of cute girls named I. That's true. That's true, maybe. Oh my god, this is so hard. I don't want to do it that way, but that makes the most sense. So basically, the way this needs to work is that we do need to nest the for loop for checking objects inside of the for loop for marching through tiles. However, it comes with a caveat. It needs to be here, but it needs to say if area index does not equal previous area index. So every time we start on a new area, we check all the objects in that area. I think that makes the most sense, because that way we have to march through the tiles using the DDA algorithm. And what that means is that we can piggyback on the DDA algorithm for figuring out which areas we actually need to check in terms of objects as well. Because otherwise, it's not so easy to actually figure out, like, which areas do we need to check. Because it could be like this. It could also be like this. Or like that. And it's not so easy to calculate which areas does this line fall into. Because it's not as easy as just saying, like, yeah, okay, it's the difference between this x and y and this x and y is like, 4 and 1. So we just check like everything here. Like, that's ass. And that doesn't tell you how often you won't need to step or anything. Or when. Because it could be like this. And then it's the same area distance. But here we step into the top one first, and here we step into the right one first. And here we step into the right one twice, you know? So I think that is how it has to be. And so here, what we have to do is we have to set int previous area index equals -1. And then in here, we have to set light map position. So then here we need to say int current area index equals get area index light map position if current area index does not equal previous area index, then previous area index equals current area index. Run object checking code for a new area. Which should just, it shouldn't be no marching, just trajectory calculations. That should be really easy. I already have the math for that. We basically just need to calculate. Well, it's not easy, but we already have like the raise position. We have the raise vector, or it's where it's pointing. So all we need to do is just calculate where we are based on the object we're checking's positions, right? And see if they intersect at all. But what's annoying is that we're gonna have to have a bunch of code to decide which axis we're gonna check with. But whatever. Oh. My brain is cooked. I'm just trying to think what should we use to determine? Are we just gonna always use Y? Does that make sense? I think it doesn't matter. As long as we use any value. I think it works. Oh. So this needs to be a for loop. It doesn't work. Um, Compute static shadow area stride. current area index dot x let's say int well, I'm a little scared of doing that. Let's do uint 2 collider count collider area collider data area data. And then here we can say area data.x. No, I don't like this. Area object start index obj count. And then you say it starts at obj start index. And then if obj id is less than obj start index plus obj count, obj id plus plus. And then we need a obj data equals compute static shadow areas obj id well, this isn't actually, this is just, that's not the obj id, this is the obj id. And then it's like compute obj data buffer. And then we access that with this index. And then we have the object data there. And this now is where we need to use math to check object. Light map position. I'm gonna open the other project. That's the easiest way to do this, because I've done this before. Is it ready? Assuming that we can fucking... decipher this. Of course. Man, I worked so much on this. It might not even be in here anymore. It should be up here. But how... it's not even that hard. It's like... it's like you have start position. Let's say our start position is 0, 0, 0. And then you have a vector 3 that is like zero 0.2, 0.6, 0.1. And then you have a target position that's 5, 8, 9. Then you need to figure out what are the values if we increment start position to the target position's values. And you basically just have to pick a value, I think. So let's say we go with y. Then you have to do something like like 8 divided by 0.6, I think. What is that? That's 13.3333333333. And then we take the start position plus the vector 3 times 13.333333. Right? And then we'll get a value of 0.2 times 0.33333 equals 0.066666. Zero 0.6 times, or 0.6 times 13.333333. which is obviously going to be 8 rounded. And then we have 0.1 times 13.33333, which is I typed something wrong there. This is 1.3333333. This is this was 0.2 times 13. So that should be 2.66666. That's what that is. I think that's how you do it. And then you can see that the values are drastically different. But then with this, you'll then check, like, this is the position. Does this fall anywhere within the object's size? Right. And then we have to check that against its light collider. But we shouldn't check our current position. We should check... We're checking the objects. So as long as that doesn't fall out of scope, we'll use that. And we're gonna use that. So we have the adjusted pixel position, but then we need a vector. We'll just calculate it here. That's the vector, or that's the direction. Or no, that's not the direction, that's the distance in each x. Hello, Clay. How's it going? No, we don't need the object data. We need the light position. Because we need the light position, we can calculate the direction back here. Light target tile position. And then this just needs to be normalized. I think. Here it is, light ray direction. This is what we need. Light ray direction. But this is a little bit of a lie. Is there I've fudged the light ray direction to never be 0, because it breaks if it's 0. Which is weird. I feel like that should be solvable. Anyway. We have an adjusted pixel position. Plus direction. But we do need the distance. That's objData.position.y minus adjusted pixel position.y. That's the distance. And then we need the float. I don't know what to call this. This is like the... dist multiplier equals object distance divided by direction dot y. That's the distance multiplier. And then we're gonna say adjusted pixel position plus direction times dist multiplier. And then we have to check if I don't feel like we have to be so anal about the size or like this. Like, is there any... I feel like we can just have a size here. Because the object data is negligible. Like it doesn't really matter if we have a lot of object data. And so I think we need to have a bunch of information here. We need position, we need size, we need float to pivot, maybe. Or we just don't. So what we can also do is see how I've done it in the past. Where is it? Here. Yeah, okay, so we then need a local position. And the local position is going to be something like object data dot position adjusted position minus object data dot position, and then we're just going to say float to position limit, or yeah, sure, position limit equals obj collection text dot dimensions xy times 0.5. Is this float 2, 3, 4 just vectors of floats? Yeah. In HLSL, you don't need to type like vector or whatever. It's just called float 3, float 2. I would say it's the vector that's the misnomer in reality, but it works it works, you know? Because a vector is just a bunch of values, which in reality is a vector is like a direction, right? But Unity and whatnot use the vectors as just like a collection of 3 floats or 3 integers, and then it uses it for a bunch of things, like transform positions and stuff. But in HLSL, you can just do whatever you want very easily. Like you just type like float. It goes up to 4. You can have an int 4, whatever. It's also a little interesting because it's got something called swizzling, which is kind of funny. So if I make like a float 4, let's just call it x. And I have this direction here, which is a float 3. If I want to fill this float 4 up with only like one of these values, if you were doing that in C#, you would have to type float 4 dir y, dir y, dir y, dir y. But in HLSL, you can type dir y, dir dot y, 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 y. And that just kind of converts it into a float 4. Or you can type xy, xy, or xyy, x, or whatever, and it'll just make a float 4 with those values from this float 3. Based on how you typed it. But this is very special because this is GPU or rendering code. So it's made like that on purpose. Because sometimes you need that kind of stuff. But yeah, so now we have to check if local position.x is less than negative pos limit.x, or local position.x is, let's say, less than or equal to. And here we'll say if it's greater than, no, less than. And here it's greater than or equal to. No, let's go. If local position is greater than or equal to negative position limit, and here it's less than position limit.x. Or in that case, it should be and. The Z is a little tricky. Pos limit dot Z equals. What should we say that is? 1. Then we have to say if it is greater than or equal to negative pos limit or 0. No. Hold on. Let's say -1. Or less than or equal to 0. Then if we are within that limit, then we'll say float for object collection text dot load int for location. So this should then be local position x, y, Wait, what does load take? Last one is just 0. Okay. So it takes int 4 something like that. And then we have to say if poll.a is not equal if call.a is greater than 0 and well, yeah, that's enough. Then we found object break break and continue to next light, else we continue. Something like this. This is some bullshit. Let's call this text limit. Data coding. So let's see. This is bool found collider equals false. And then here we'll say found collider equals true. And then we will break. And then here we're gonna say for found collider, if found collider then we will break. Because this is marching through piles. Checking. No. For every new area entered, check objects. Something like that. This I should remove all of this, I think. I actually don't know if the way I'm testing now is actually gonna work well, but there's only one way to figure that out. But yeah, this should be commented out. There's an error here somewhere, but... Oh, I see. Going to fetch a color that's baked, but no. We don't need that. Now, I don't know what the value is here, if it's 0 to 1 or if it's... coffee. And even this is... I basically have to do this twice. Which sucks a little bit. Because this has to... And that should warrant breaking it out. But... Didn't know this counts as a variable for the rest of the scope. Because I'm passing in the light that we're checking. That does light cast twice. But we actually need to do it like, or it does it like that, and then we need to do it here again, because I need to do a pass against the static light and one against the dynamic light. And then down here, it says ray cast loop. I actually don't know what to put in there. If Z equals 0. Maybe something like that. That might actually compile, but I strongly doubt it works. Invalid type for index. Index must be a scalar. What? Wait, what? Is it just this? Let's see, here it says PS main. It doesn't go to the one that shows the error. 5560. 5560. 5560. It's this one. These are integers. Kernel upload dynamic light area data. Here. Dynamic light area data. Dynamic light area data. What is the problem? Uh, what is the problem? 5560. Apparently it's index supposed to be that. That didn't help. 5575. Okay, it did help. Now there's something on 5575. The compute tile data. Flattened chord. High value specifies const object. It's a read, it's not a read write. Compute tile data. Okay. They should pretty much all be read write. Variable compute tile data used without being fully initialized. We have more stuff here now. Hello, Reticle. How's it going? Right. Tile data, tile state, tile type. Swallowed incorrectly. I think we're pretty close to done for today. I need to here upload tile data. I'm gonna put that in the docs. Upload tile data needs to be finished as it does not contain all of the data a tile consists of. And then we'll see like exactly how much work we'll have to do on the actual like the light loop to get that to work. And I'll also have to, I mean, I feel like it shouldn't be that much work to get it to work again, because I haven't really changed the actual like buffers that much. It's mostly that I've changed how I write to them. Which was borderline unnecessary. I don't think it was actually unnecessary, but it was like borderline because Unity lies about how its buffer modes work. So we should be able to render like something on the screen, and then it's gonna look completely wrong and incorrect, and then we'll have to figure out how to fix that, because it is gonna be messed up. The way things were done weren't quite right. But we shall see. Were I using like little arrays? Or like light, no. Light, a color array. Yeah, compute color data array. This is not good. I don't know if I can do it without. Yeah, I don't know if I actually can do it without. That's the issue. Because see, the issue is that we're rendering from... We're rendering top to bottom. And because of that, we don't know what we are drawing to. And what that means is that because we're going from top to bottom, we're going through, we might find a wall. That wall might be semi-transparent. And that means we have to store the color of that wall as we continue until we find the next thing. And the next thing might be another transparent wall, and then we need to store that until we find something that is opaque so we can mix them together. Because whatever we found might have a different blend mode. Because it might be an object. And that's where the issue comes in, where I have to have like this kind of array of color data, which is this much data, which means that we have 128, 180, 192, 256, I guess. 256 bits times 20 per pixel that we're rendering. But I could reduce this as well. 20 is quite extreme. But the issue is you can't really blend it properly otherwise, because like if I blend the transparencies together as we go down, then you can't have like hard light, for example, as a blend mode in the game. Because the hard light needs to have something below it to combine with. And if we then, we just have like normal transparency that we're mixing first, like we find an object with normal transparency, then we find another one with normal transparency. Mixing those is okay. But then when we find the third one, and that one has a hard light blend mode, you can't mix those together, because what are you going to do now? You're just going to mix the colors and then set all of it to hard light? That doesn't make sense. Because then we're not mixing layers together properly. And it's going to make like whatever is in front have like a weird glow that the hard light is going to be creating incorrectly. So it has to be something like this, which is ass, but it is what it is. And I think it's tolerable. I think it's a bad solution that we can manage. But it is a bad solution. The only alternative would be to render in reverse. And I feel like that's even worse. Like, at the end of the day, it's a performance loss. The question is just, what is the bigger performance loss? And what I could do is I could start rendering from, like, the bottom. But the issue with that is that the bottom might be... like, we don't know where the bottom is necessarily. So I would have to render from the bottom and up. And then we would have to just, like, whenever we find a new opaque tile, we have to just, like, discard the previous one. And if I do it that way, then it would make sense to combine transparencies no matter the blend mode, because it would be done in a bottom-up order. But, I think it's okay. Oh yeah. But yeah, we have a meeting soon, and I think that we're done for today. That's my brain is not going to be able to do much more on this. But I know what we need to do next. And then we'll see what we can manage. Anyway, until next time, thanks for hanging. Have a good day. Bye-bye.